Yeah, hello. Thank you. And yes, I'm going to talk about security. First of all, I think I do this little introduction as... So, yeah, my name is Bastian. I'm worked with Magento for 1.5 years now. I'm also a certified developer for a few months now. And IT security and developing is a hobby for me for 5 years now. It's just a hobby, not my job, but well, also I'm doing my apprenticeship at Wikimedia. It's basically what I'm working right now. It's a bit different in German. You can ask me later if you have questions about this. Okay, security in Magento. Usually these are the points you see on blog posts. Oh, sorry. Hide your admin path, encrypt your data, use strong passwords with numbers and characters, and set file permissions on your web server, and so on. This is what you get everywhere, but this is for sure not everything. What I'm talking about today is this. The definition of security for sure, what does it mean? Then a quick overview about security in e-commerce in Magento. Then the most common issues people made, the most bug they made, the most mistakes. Then for sure the best practices to show you how you can secure your software. And as a little special, I have 2 example attacks. With the example attacks, I don't want to show you how easy it is to hack Magento. These are hacks on Magento, but I still, compared to other software, Magento is still one of the most secure software I ever saw. Okay, let's go on. What does security mean? This is from Wikipedia. Security is the degree of protection against danger, damage, loss, and crime. Security as a form of protection are structures and processes that provide or improve security as a condition. Well, what does this mean? This means, in this case, it's not for IT security, but it's similar. So security means all the parts we need to secure our stuff. We can secure our house by building walls around it. We can secure our cars by using seat belts, and we can also secure our shops, our Magento shops, by avoiding mistakes. But it's a bit different, because if you have your house, you can start building walls around it and higher walls and bigger walls. That's not what you can do on security on IT systems, and we'll see later why. Okay, computer security. This is for sure a very new topic. The first attacks on computer security infrastructure were the Morris worm in 1988. This was basically the first real attack. It was a worm, and this was a time when everyone had an administrator account with a password admin. But that was the time when the people started to think about computer security. Well, compared to for example, security in a car, computer security is based on logical problems and not something weak, like weak material, weak stuff. You know what I mean. And it's absolutely not as shown as in movies like Matrix, Password, Swordfish, or Hackers, where they are always blinking and blinking consoles and always a lot of weird and fast hacks. It's totally different. Okay, now I want to show you my first attack. I found this about 1 year ago, basically during the last Imagine. It's fixed in 1.5.1.0. And yeah. So this is a clean 1501 Magento installation. It has 1 test product, $10. Add to cart. Check out. I think everyone knows this process. $5 shipping. And place it. So we now purchase the test product for $10. And In the backend, we now have the order, $15. Status right now is pending. So now the bot's golden gift card, it's a little exploit. An exploit is basically a little script or a little program which allows to attack a specified issue. The script, I can't show you the script itself, but I can show you what it does. It's able to change this order status in Magento. So basically it's quite easy. We need the host, the path, the order ID, the amount, and the action we want to do. We have basically 4 actions: fail it or cancel it, set it back to pending, and set it to paid. So let's try it. Mage.local is the host. Yep. The order ID was come on. The amount is $15. And now we can set it to a pending payment, which is necessary to set it later to paid. So it's really fast. It creates a faked authentication token from the payment gateway. Now, if we reload the page in the admin, we see the status changed. Now it's pending payment. Now, if we set it, it creates a new token. Payment failed. Oh, okay, I'm sorry. It's okay, one moment, sorry, please. Oh, not this. Okay. So now it's a processing order, and I just typed the wrong things. So we see the server response, the amount has been authorized and captured. Here we see the pending bank transfer was created, and so on. So we are able to control the order status of basically every order just by knowing the order ID and the amount. So how does it work? Basically, this payment module has a function validate data. I changed for sure the module name and the method name, but this validate data uses 4 variables to ensure that the payment or the response from the gateway is the right one. So it uses a merchant and secret. These both are set up in the backend. The other ones, order ID, amount, currency, and status, is all we know already, because the order ID and the amount and the currency in this case is US dollar. The status is the number we set. So the point is merchant and secret, they both are empty by default because this module is in the core, it's active, but the most, I would say about 85% don't use this model. So it's active, but with 2 empty secret arguments. So this is basically how the key is created. Secret and merchant, as I said, is empty, so it changed to this. And order ID, amount, and currency are the 3 things we already know. So we can create an authentication token for every shop which doesn't use this payment module and set the order status there or how we want. Yes, well, security in Magento. There are a few problems. The first is a complex source code. As of Magento 1.7 release candidate 1, we have near 2 million lines of code, 12,000 files, and 373 database tables in the default installation. This is for sure too much for one person or for 10 person or for also more persons to check everything and every connection between the modules. So we have also a lot of merchants, which results in many possible targets, a lot of transaction data like credit card data, and also a lot of customer data like the matching names for the credit cards, the addresses, enough to fake identities, enough to fake transactions or steal credit cards. And also we have a lot of developers, as I see. But the problem is security is a very unknown topic in a developer scene. First, we don't have many attacks as references. And there are also very small information about more advanced security than just MySQL injection or cross-site scripting. But the good points are Magento 2 will be checked against the OWASP top 10. The OWASP top 10 is a list of the most common security issues and the most common mistakes in security. And also they have for more than 1 year now a security team which takes really good care about these issues. Okay, and we have Magento Connect with more than 5,000 extensions. The problem is there are a lot of insecure payment modules, and obviously it's impossible to check everything, and also for Magento. They were thinking about this, but it's just too much. Also, it's a problem because some modules use encrypted source code, like with IonCube or I think Thantest, something like this. And it's impossible to check the source code and to check for security issues. Yeah, so the best targets if you try to attack a store are for sure payment modules, because they directly affect the payment process and the order status. Also price rules and or reward modules, because they also directly have an impact on the payment, and you can use them if they are not if they are vulnerable to attack or to change the amount of orders, for example. And also, of course, the core infrastructure, because this is what is built below everything. And if the core infrastructure is vulnerable, you can basically control everything else and do whatever you want. This leads me to the next attack. It's an attack on the API in Magento. It's also fixed. So the API is, you all know them. You have a web user, so this is basically a little script which just reads the product collection. There's only one test product in the store. I can show you the source code. Oh, sorry. It just logs into the Magento. It's hard-coded there, calls the product.list method and displays it. So now I have a second script, a Python script, because it's faster, which is able to take over the API or the API user. If I now start it, it needs a few seconds. And now, as you see, it displays the order collection. This is the order I created a few minutes ago. Everything. So this happens just because of two problems. There is a bug in the API which allows me to access the API. I can't show you the source code for sure, but I can grab for the API username or the password in this file to show you that I'm not using it somewhere in it. So the problem is, as I said, one is the bug, but the bug wouldn't be this critical if the user, as we see here, services. Oh, sorry, wrong host. Whatever. The user is an administrator user which has access everywhere. So if we now have an API user which who is only responsible for updating the price of a product. Well, or just read the product list, because, for example, to send them to eBay or Amazon or whatever, it should not be an admin user which has access also to the order collection. And this is, in this case, the test user is an administrator, so I can get his credentials or hack his account and get the order collection. So, well, that was the abstract explanation. I hope it's clear enough. If you have questions, you can ask me later. Okay, let's go on with the most common issues. These are the most common attacks on PHP, especially PHP web software. First of all, MySQL injection. I think you all know the word MySQL injection. It's well known, but still very dangerous, and on the OWASP top 10, I think on the third most exploited issues in softwares, in web software still. So basically it's based on the injection of special crafted MySQL code into a query, which means there's a query which is executed somewhere, and an attacker is able to change this whole query and put his own SQL code in it to, for example, change a select from a product page to a select from the admin page. So this looks basically like this. So this is a very, very abstract example. We just have a select on field 1 and field 2 from table 1. And we use this $_get entry as a variable to get the ID we want to fetch. Here is nothing checked. So usually it looks like this. For example, to fetch the first entry, it might be on a CMS page on a little software, wherever. So now an attacker can change this number 1 to this string. The first part, lower than 1, means that the first select don't get any results. Then it uses a union select to append a second query with the username and the password from the users table where admin is 1 and the limit 1 to get the first admin user. This would result in a query which has field 1 and field 2 but contains the administrator credentials. This is in this case, so how it is in this way not usable in Magento. Magento use prepared statements which are secure against these injections. But I saw modules on Magento Connect which really use code like this. And this is just ridiculous because Magento has enough features and enough functions to secure everything. So let's go on. Cross-site scripting. Cross-site scripting is basically in the injection of JavaScript code into home pages. There are two kinds of it. There's the non-persistent, which is a specially crafted link or a formula. For example, you have to send to, for example, an administrator. This needs a bit social engineering, which means you have to send him a mail, please click on this link, and you have to imagine a funny story why he should click on the link. These are not that they exist and they are important, but not as dangerous as persistent in cross-site scripting issues. Persistent cross-site scripting issues are, for example, JavaScript, for example, from a search query or something like this, which is stored somewhere, for example, in the database and always displayed on a special page. So as soon as the administrator clicks on this page, the JavaScript code is executed. And as soon as the JavaScript code is executed, the JavaScript code can simulate browser requests, for example, on the create new administrator formula. So this form, which results in adding a new user just by a little JavaScript code. And based that the most, for example, also Magento use the prototype framework everywhere. So the attack also has frameworks for AJAX requests, which makes it for an attacker really easy. The good points in Magento right now, there are no cross-site scripting issues, but there are, for example, in modules. And the code, for an example, basically looks like this. This is a just a little search formula with an input, and if it use mage get request get param q for the query to print it after a query to have these search query still in the box. So the problem is, this is how it looks usually. Someone searches for test, and then it appears also in this box, and there somewhere you were looking for test, whatever. But an attacker now could use this. Here, it stops it closes the HTML tag, and then it adds a new script tag for JavaScript code. In this case, it only shows a little message box which shows us JS code injection. But it's also possible to load other JavaScript code or to, well, basically do whatever the attacker wants. Yeah, cryptography, the next big topic. There are a lot of mistakes in cryptography because a lot of people don't know cryptography. For myself, I'm also not very good in it, but there are a few basics you should know. So first is use SHA 256 instead of MD5. MD5 is used everywhere, but there are big tables on the internet who have the plain text and the MD5 hash. So you just have to put the MD5 hash there, and it shows you after a few seconds the right plain text. SHA 256 uses more and wider strings, so it needs more computing power and larger tables to build this. And it needs a few more time, just a few milliseconds, but this also results in stronger cryptography. Also, it just needs a few seconds to find a collision into MD5. This means it's on a good computer, it's very easy to find two plain texts, which results in the same MD5 hash, which also led us to, for example, fake some data by using two different plain texts for the same MD5 hash. Also, a very important point is do not use time for random data. I saw it often. I saw it also in the Magento core. I saw it in modules everywhere. There's a simple function, empty_rand, which has perfect random data. If you use time, everyone who knows when this time function is called can look on the clock and see, oh, it's the timestamp right now, so the key or whatever is exactly what my clocks show me. This is obviously not secure. And a good reference is the Mage core model encryption, which has a lot of functions for unique keys, for encrypt data, for everything like this. You should check it out. Just take a look on it. It's easy to use and has a lot of good methods. Yeah, then I want to show you two unknown attack vectors, unserialized and simple XML load string. These both functions are dangerous too, because if an attacker is able to send a string as an argument to one of these functions, he could be able to take over the server. First, unserialize. Unserialize is used to transform the serialized data back into an array or an object. First look, it looks good. But the problem is, if it unserialized an object, it's called the wakeup and the destruct method. Most of the time, the wakeup method is not used in the most classes. But the destructor is somewhere in Magento, and then there are classes which use this destruct to unlink a file. So if you now are able to send a special crafted string as an attacker to the unserialized function, you can, for example, unlink the htaccess file in the app folder and then just take a request on app etc local XML to get the database configuration. But the good point is, Magento core don't use unserialize on user input. But there might be extensions which use it. So you should also be careful with this function. And the other function is simple XML load string. The problem with it is there are doc type entities which can act together with protocol wrappers result in file disclosure, which means it can be used to read local files on the server. The good point is it's also not applicable in Magento, but it's really easy to exploit. It's basically, if you use this little XML code and put it into simple XML load strings, these ampersand XXE tag let the XML parser read the file /etc/passwd and put it inside the foo tags, which obviously results in a way to read local files on the server. So you should be sure there's no one able to put doc-type entities into the arguments for simple XML load string, or better, don't use user input or something like this in simple XML load string. Well, now a little look on the best practices. First, review the code as if you would be the attacker. Means, took a look on your code, and what would you do if you want to hack your software? What could result in a bug? I know it's not an easy topic, and I can't teach you everything right now, but it's also with the 4 eyes principle. You should just take a look on it, serious, and think, okay, this could be a bug, and maybe someone finds a way to exploit it. Because the point is, an attacker usually don't care if an exploit is complex or not. There are, for example, exploits in browsers like in Firefox or Internet Explorers. There were teams with 3 or 4 people working for months on only one security issue to exploit them. So you should never think an exploit or an issue is too hard to exploit. And also it's very good to follow the frameworks and coding guidelines, because they usually have enough functions like prepared statements. They have functions to serialize data and unserialize them, to sanitize user input, to make it secure against cross-site scripting and so on. So just use the frameworks and follow the coding guidelines, and don't try to write it by yourself, because this the most people were thinking when they wrote the code, like in Zend, sometimes. Okay, issue found. What to do if you find an issue in a software? Well, there are basically 2 ways, full disclosure and half disclosure. Full disclosure means just put the exploit and everything information about it just on the internet. This results in fame and maybe a lot of angry people who get hacked servers, and that's basically everything. I'm following half disclosure. I send every issue to Magento, and now, as like today, I show you something about this, but it's just because I would not like to see my exploits or exploits for my software online. I think it's usually the better way to give it to the vendor than to publish it somewhere else, because, well, I think it's just the right way, the good way. And yeah, so you can inform the vendor or ask me if you find something. Well, so this leads us to the conclusion. Software can't be safe, but we can make it hard to exploit. And of course, never trust the user input. So these are the 2 last statements you should keep in mind when writing Magento modules or other software. Yeah, that's all. Thank you for listening. If you have any questions, feel free to ask. Oops, sorry. So.